Hi, this is Alex from devstories.eu. Docker Masterclass, Episode 1 of 18. You just spent 3 days hunting down an error that only triggers on the staging server. The code executes flawlessly on your laptop, but the moment it hits the deployment pipeline, it breaks. The culprit is almost always a mismatched system library, a different runtime version, or a missing environment variable. This is the exact friction Docker was built to eliminate by delivering the dev equals prod promise. Docker is an open platform for developing, shipping, and running applications. Its core purpose is to separate your applications from your infrastructure. Historically, developers wrote code in operations teams' provisioned servers. The developers would hand off the application, and the operations team would spend hours or days configuring the host machine to meet the software requirements. This manual alignment of environments is fragile and slow. Docker solves this by packaging the application together with its dependencies, system tools, libraries, and runtime into a standardized unit called a container. You might associate this concept with traditional virtual machines. While they share the goal of isolating applications, containers are vastly lighter because they do not require a full guest operating system. We will cover that architectural difference in the next episode. The focus right now is on what this packaging achieves. Here is the key insight. Because the container holds both the code and the precise environment needed to execute it, the underlying host machine becomes largely irrelevant. Docker ensures that if a container runs on your local development laptop, it will run exactly the same way on a quality assurance server and exactly the same way in a production data center. You eliminate the phrase, "it works on my machine," because your machine and the production machine are now providing the exact same execution environment. The workflow looks like this. A developer writes code locally and defines the required environment in a plain text configuration file. Docker reads that file and builds a static artifact called an image. That single, immutable image is what gets tested. When the tests pass, that exact same image is deployed to production. You are not copying code to a server and running a setup script. You are moving the entire working environment as one sealed unit. This portability changes how systems scale. Because containers are standardized and lightweight, spinning up new instances of an application in response to a traffic spike happens in seconds. You can easily shift workloads across different environments, moving an application from a local testing server to a cloud provider without changing a single line of code or reconfiguring the host machine. The ultimate takeaway is that Docker transforms infrastructure into a predictable commodity, creating a rigid boundary where developers own the complete environment inside the container, and operations simply provides the compute power to run it. If you want to help support the show, search for Dev Stories EU on Patreon. That is all for this one. Thanks for listening and keep building.